So we're in our homework book, right?
Right now, we're not working on the homework.
So just show
Right now, we're working on the other book.
That's a.
Look,
Oh,
F3C1.
yeah, same thing, so, okay, see.
Okay? So, modeling quadratic. So basically what we're going to explore right now, we're going to explore how does the table of value look like for a quadratic equation, how does the equation look like for a quadratic, and how does the graph look like. Okay? So the first thing that we're going to look at is the distance traveled by a boy on a bike is modeled by the equation y equals 3x. Looking at this equation, can you tell me if it is a quadratic equation?
Wow, there's 3 of them.
We look on.
No, there's only 2
I have 3.
because you have 3 of the same thing. Show me what you have. Yeah, that's all. So, can you guys tell me if this is quadratic? Look at this. Is this quadratic? Why not? There's no
2x exponent.
2 on the as an exponent, right? You don't have this, do you? I'm gonna erase that. You have that? No. Since I don't have that, then this is called a linear equation. Okay? Now, if I'm looking at the table of value, look what's gonna happen. So the first table of value is done for you already. Okay? But look what happened. So I gave you the x values 0, 1, 2, 3, 4. And then you're gonna replace the x right here. You're gonna replace that x with a 0. So it becomes 3 times 0, which is 0. Yeah? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 4 times 3 or 3 times 4 is 12. Okay? So where did I get this from? What I did is I replaced these x values in for x to solve for y. Makes sense or not?
Yeah.
Makes sense. So when x is 0, y is 0. When x is 1, y is 3. When x is 2, y is 6. And so on and so forth.
So in this case, x is 0, right?
You have different values for x. X 0, 1, 2, 3, 4.
Yeah, but, okay.
We're going to see it on the graph and it will make more sense. Okay? So, the important that you need, this and this are very important for graphing. Okay? Now, what does that first column mean? The first column, this one, is actually called the first difference. What does the word difference mean in math? When I say difference, subtraction. Okay? So the first difference is the first subtraction. And when I'm doing the first difference, I'm subtracting my y values from each other. So this is what happens. I'm on the board and I'll let you guys copy this. So to find the first difference, you have to start with the bottom y and subtract it from the top. So it'll be 3, take away 0, and that's a 3. Okay? Then for the next one, I'm going to have to do 6, take away 3. And that's going to be 3. 9, take away 6. 3. 12, take away 9. 3. Did you notice something about the first difference? They're all the same. They're all 3. Right? And that is a characteristic of linear functions. Linear functions, their first difference is always going to be constant. So it's always going to be the same. So, if you're looking at a table of value and you are given the x and y, and you do the first difference, and the first difference is constant, then right away you can say it's a linear function because the first difference is constant. Done. Do I need to repeat that?
It's linear because the first is constant.
The first difference is constant. That's right. Okay? So if you have a table of value and you do your first difference, which is the y values, you subtract the y values, and it's constant, that means it's linear. Now,
So x you multiply and y you subtract?
the reason why I'm multiplying is because I have 3 times x. Okay? So I do 3 times whatever the x value is.
Okay, so why you subtract?
Because it's called the first difference. This is a test. You know how you test if you have a linear function? This is how you test it. Okay? If I do this, take away this, take away this, and I get all the same answer, then right away I can say that it is a linear because the first difference is constant. Okay? This is a way to test your functions. Okay? Let's graph this. What's my first point? 0 what? 0, 0. Right? This is my first point. Where is 0, 0 located? Right here. Okay? What's my second point? 1, 3. 1, 3 is right here. What's my second point? 2, 6. And third point is 3, 9. And then 4.
12 now.
Straight line.
So the one in the first indefinite graph?
So this
That first one.
and this and this is a 1 point. X, Y. X, Y. Are we okay with that? Do we all know how to locate the points on the grid? Yes.
We look at the x and the y value.
That's right. And then the X is on the horizontal, the Y is on the vertical. Okay. So far we looked at 3 things. We looked at the equation and we decided that it's linear because X doesn't have an exponent of 2, has an exponent of 1 that we don't write. Then we looked at the table of value, we did the first difference, and then the first difference was constant. So since the first difference is constant, that means it's a linear function. We also graphed it, and the graph showed a straight line. So that means it's linear. Okay? 3 different forms confirming the same thing. Let's look at the second equation. So the only marble is recorded and modeled by the equation y equals negative 5x plus 2. Looking at the equation, can you guys tell me what kind of function is this?
Linear?
Linear. Why is it linear?
There's no exponent.
It's degree 1. Okay? It's a degree of 1 or exponent of 1. It's the exponent, since there is no exponent, it's actually 1. So this is the reasoning for it. So linear degree 1. Okay? So if I asked you that question, if I gave you that equation and I asked you what kind of function it is, you're going to have to say it's linear. And if I asked you, give me a reason for it, you're going to say it's a degree 1.
So for the first one, here.
same thing.
Limit is degree 1?
Yep. Right? If the x doesn't have an exponent on top of it, it's an exponent of 1. Now, let's fill out the table of values. Again, I gave you the x values that I want you to use. So all what you have to do, you have to plug in the x value in for the x. Okay? So if x is 0, you plug in 0 here, and then you're going to get negative 5 times 0 plus 2. Negative 5 times 0 is 0, plus 2 is 2. Are we okay with that?
Yes.
Okay. What will be the answer for x is 1? Because I have negative 5 plus 2. So that is negative 3. How about for the next one?
Negative 1? Negative 1?
So what's negative 5 times 2?
Oh, yes. Negative 5 times 2.
It's going to be negative 8 altogether. Negative 5 times 2 is 10, is negative 10.
Yeah, I think.
And then add 2 to it, it's going to be negative 8. So that is negative 10 plus 2. So the answer is negative 8.
Negative 13.
Yep. So I have negative 15 plus 2, so that's negative 13.
And then last one, negative 18.
Okay? So this is how you find your table of values. Given the equation, right? All what you do, you plug in the values of x in, and then you find the y value. Are you guys okay with that part? Okay. Now I'm looking for the first difference. What do I have to do?
What do you do? Subtract the top?
Minus.
So like 3 plus 2.
Negative 3 take away 2.
Yeah,
Right? Negative 3 take away 2. So what does that equal to?
Negative 1?
Negative 5.
Oh, shoot.
You're at negative 3, and you're moving 2 steps backward. How about the next one?
Negative 11, 5.
It's not negative 11. I want you guys to put your pencils down and look here for a second. So negative 8 take away negative 3. What happens when I have negative and negative together? Positive. So that's negative 8 plus 3, which is negative 5.
Also, all of them give you negative 5.
They're all going to be negative 5. But let's prove it. Okay? Negative 13 take away negative 8. Negative and negative makes a positive, so that will be negative 13 plus 8, which is negative 5. And then negative 18 take away negative 13, that's also negative 5. First difference is constant, that means linear function. I'm going to write that. First difference constant. Therefore, it's a linear slope. Yes.
When you say first difference is constant, what do you mean by that exactly?
You see how my first difference had the same answer, negative 5, negative 5, negative 5?
Yeah.
So that's a constant value because the same value is the same thing, right? Constant means the same.
What
Okay.
you have written, you will make a constant and linear, what is the sign?
That's a sign, that's called therefore. It looks like this. Oops. This sign right here, it represents therefore.
Oh.
So we don't have to write therefore too many times. Okay?
And the opposite of this is because, right? If,
Sorry?
if you convert it, opposite way,
It would be
become
because. That's right.
Like that.
Mhm.
Because when I was in school, yeah, I write that.
Therefore. Okay, so let's graph this. Now when I look at my y values, I want more negative y values. So I always think ahead of time when I'm trying to put my x and y axis, right? So if you see that I'm going to graph this, I'm going to have more negative values than positive values, right? Because negative y. And I think I'm going to go up by 2. You might not be able to fit all the points, and that's fine. So my first point is at 0, 2. So it's right here. Then it's 1, negative 3. Two, negative 8. 3, negative 13. I probably can fit that. But then I can't fit the last one because I have no, which is fine. So I can draw a line between all these points, sorry. You can always extend the line before and after because the line is continuous. It's gonna keep going. It's not gonna stop. Okay, so let's just recall this. So this point is right here is 1, negative 3, right? Comes from this.
How was the first point? How you plotted? The first point, top.
0, 2.
0, 2, oh, I could not.
0, 2.
Okay.
Right? It's a y-intercept. X is 0, y is 2. And then 2, negative 8. Right? 2, negative 8. And then 3 and negative 8. How does the graph look like?
That's right.
It's a straight line. It's a straight line. Okay? So we have to write it's a straight line.
It's not 8 line. It's like
It is decreasing, but it's still a straight line. Right? It's decreasing, it's going down, but it's a straight line. Okay. How are you guys doing with this? Are we getting it a little bit? Yes. Compliments. Okay. Moving on.
Well, so what do you call the other one?
height of the
Which
top.
one?
The first one.
Straight line. Right? As long as it's a line, it's a straight line that nothing's happening to it, right?
Okay.
And that's why it's linear. We know that. Okay. Let's look at our third example. The height of a ball thrown by a child is modeled by the equation y equals negative 2x squared plus 8. What is this? Quadratic. Why is it quadratic?
Because square.
Degree 2.
And how to pronounce the equation? It starts with a Q. I don't.
Y equals negative 2.
No, I mean, what is this word? How to pronounce?
This one?
No, yes.
Quadratic.
What is
Quadratic.
Because I hear it first time. That's it.
It's quadratic. Okay, now let's make the table of values. Okay? So I picked the values for you, 0, 1, 2, 3, 4, right? And then if I plug in 0 in for x, I would get -2 bracket 0 squared plus 8. What does that math tell me? What do I have to do first? Brackets. I have nothing to simplify inside the bracket, so what's after that?
What?
Then e. Exponent. 0 squared is 0. Multiply by -2, 0.
Yeah.
Plus it.
Plus 8 is 8. Okay? Let's do the next one together. So -2, 1 squared plus 8. 1 squared is 1 times -2, so that's -2 plus 8, 6.
So it's not constant.
We haven't done the first difference yet.
Oh, yeah.
Yeah, we will do later.
Okay. 4 times -2. 4 times -2. -8 plus 8. 0.
Oh, mine is mine.
-8 plus 8 is 0. Okay. -2, 3 squared plus 8. 3 squared is 9. 9 times -2 is -18 plus 8 is negative. Let's see if you can do that without calculator.
What number is that?
That's a 4 squared. Sorry. No. 4 squared is
8.
16 times -2, -32.
32 times 8. Because of 4 is 8 times 2 is 16.
Okay, so let's take this on the side. Don't write here because I'm gonna have to graph. I can't read.
Yeah, so -2 times
4 squared.
4 is 16.
4 squared is 16.
What is negative 10?
Minus 32.
16 times -2
Minus 32.
is -32. -32 plus 8,
Minus 24.
-24. Right? All right. Now I'm done my table of values. I'm gonna erase this. Hold on. Hi. Okay. In the first difference, what do I have to do?
Oh, 6
Subtract.
6 subtracts 8.
That's right. 6 take away 8. What do you get when you do 6 take away 8? -2.
They're in my head, actually.
Well, if I tell you the temperature is outside is 20 degrees, you're probably gonna take off your jacket and you're gonna go run outside in your
Yeah,
shorts.
but that's weather.
No, it's the same thing.
That's weather.
Or if I say you have $1,000 in your bank account and you actually owe me $1,000, there's a big difference.
Yeah.
Big difference there. -2 and 2 are not the same. Okay, how about, then what do I have to do next? 0 take away 6, what is that?
0.
Oh, 6.
Well, you,
-6.
Wait, why is it a minus? 6 and 8 are not. Why have to go -2?
6 take away 8 is -2.
Why is it -2?
Because
You're at 6, and you're moving 8 back. So 1, 2, 3, 4, 5, 6, and then 2 more. Right? That's a bad drawing.
it goes more than
So you're moving 8 backward. 1, 2, 3, 4, 5, 6, 7, 8.
minus 2.
Right?
Number line.
What's 6 take away 6? 0. But you're taking away 8.
Okay,
So you owe me 2.
I just don't understand why is it always positive? Right? Like why is it always negative?
It's not all because you're subtracting 0, take away a bigger number. You're taking away a bigger number. Okay. Now negative 10, take away 0. What do you get?
Bracket goes down, so it's positive 10.
Negative 10?
Negative 10. You're at negative 10 and you're taking away nothing. Right? Negative 24, take away negative 10.
Negative 14.
Negative 14. Because negative and negative makes positive, right?
Right.
So negative 24 plus 10 is negative 14. Now, what can you tell me about the first difference? They're not constant, right? It's different. You see that? So you see that negative 2, negative 6, negative 10, negative 14. They're not the same. So that means I can say right away that it's not linear. But how can I tell if it is quadratic?
Yeah, the exponent is 2.
The exponent is 2. But how can I tell from the table of values? There's an extra step that I have to do. The minute that your first difference is not constant, then you have to go to the second difference. Okay? So the second difference means
Negative.
I have to subtract this from this. Okay? So negative 6, take away negative 2. Negative 6 take away negative 2, so that's negative 6 plus 2, so that's negative 4. Then I have to go negative 10, take away negative 6. So that's negative 10 plus 6, which is?
Negative 4.
Negative 4. You start seeing what's happening here? Negative 14, take away negative 10, is negative 4. What can you tell me about the second difference?
Linear.
Linear.
This is linear.
Or-
The constant. The word is constant.
Yeah, that thing would do.
Okay? So, second difference is constant. Therefore, that tells me it's quadratic. So, you see how it said first difference is constant, therefore it's a linear function? If the second difference is constant, therefore it's a quadratic function.
What if the second difference wasn't?
Then it's neither.
And what would be the name of that?
We just say neither for you guys. You just say neither.
Okay.
Yeah. The question will ask you, is it linear, quadratic, or neither? In this case, it's quadratic.
Second difference.
Is your brain hurting yet?
Yeah.
Yep.
Yes. This is my goal. Okay. Okay, right. Eating chips did not help. Now it's chocolate time because he needs that brain power. Alright? Okay. So, equation, if it's degree 2, it's quadratic. Table of value, if the second difference is constant, it's quadratic. Let's look at how it's going to look like in the graph. This is not going to be your best graph, but it's going to do the trick. Okay? Let's do it. I'm going to have to plan ahead. I have negative y values, negative y values, some positive y values. So I'm going to go like this.
One question about linear, so we don't have to do a second bit, right?
No.
If you find out it's linear.
If you find out that it's constant, you stop. You don't do
Only when
anything.
it's quadratic, you might.
That's right. Because it's not constant, you see? Then you have to go to the next step. That was a good question. So if you notice that your first difference is constant, you don't have to worry about your second difference, right? You just don't worry about this.
How do you also go empty?
Okay? You leave it empty, please. All right. So let's try to figure out how am I gonna do this. Oops. I made a mistake. Don't copy. I'm gonna go up by 3. Now, something that I've noticed a lot in my previous 11s, that they tend to change the scale on the y-axis to suit their needs. So basically, they start going up by 3, but then they go up by 10, then they go up by 20, just so they can fit all the points. Please don't. If you start going up by 3, you're gonna have to keep going up by 3. Okay? You can't change it in the middle of the question. Okay? So you see how I went 3, 6, 9? You can't go 3, 6, 19 because you want to fit a 19 point somewhere. Okay? So that's going to be also going down. It's going to be -3, -6. You can choose the scale that you want as long as you stick with that scale. Right? You see that I might not be able to fit the -24. It's okay. I don't need all the points. Okay? So my first point is 0, 8. So 0, 8 is about right here. Right? Just below the 9. 1, 6. 2, 0. 3, -10. 4, it's going to be -24, so it's going to be about right here, okay? So if I draw a line, right, that fits through the points, what do you guys see? Is it going to fit the other 2 points?
No, it's not.
No, so it can't be a line, right? Has to be a curve. So that's why I have to go, oops, I have to go more curved. Okay? Now, if you guys remember, a quadratic is going to look like this, or it's going to look like that. Right? What I have here is part of my graph. Okay? Probably my other part is going to be on the other side, but I can't graph it because I don't have the points. Okay? That's why I put it as a dash. So I can't graph it because I don't know what these points are. Okay? Are you guys okay with this?
Yeah.
Quadratic, quadratic, quadratic.
Because it's curved, it's not straight.
That's right. That's exactly what it is. And we call the quadratic a parabola. Okay? This is the name of the shape of the graph. It's called a parabola. Okay? Some people like to call it parabola. I don't think so.
Asian people.
They're like, I think I remember it more. Okay. So what I'm going to do right now is I'm going to leave you with the next question. So I would like you to explore the next question a little bit. Try to fill out that table, work with someone, and then I'll put the values on the board for you so you can match it with yours. Okay?